Everybody, today we're doing an equation that involves a ceiling function. So let's briefly review what the ceiling function does. It's the opposite of the floor function, more or less. Now we're working with irrational constant on the right-hand side. So let's take the ceiling of, let's say, the square root of 83. This is just arbitrary to familiarize you with the ceiling function if you haven't seen it. Okay, now this, if you take a look at what's going on here, the square root of 81 is 9. So the next highest integer is going to be a number bigger than 9, which would be 10. Okay, so the ceiling of this is 10, but that's simply because 9 is less than square root of 83 is less than 10. We have to say less than or equal to 10 because the ceiling of the constant is the constant, so we'll put less than or equal to. Okay, so that's just a brief example of what the ceiling function does. It returns the least integer that's greater than the input argument. Well, the input argument's a little bit bigger than 9, so the next integer would be 10. Okay. Now, let's also take a look at a statement here that's going to help us to solve this. And this right here, this piece right here is just based on the fact that 23 squared, this may be easier to process right here. 23 squared is less than 560. Is less than 24 squared, right? And if you take the fourth roots all the way through this, the fourth root is an increasing function, you would get this statement right here. And you may ask, well, why is this important? Well, just take a look at what we have right here. This is approximately, and I'll put approximately in kind of a vaguer sense here. This is approximately the same thing as just x squared is equal to the square root of 560, right? Okay. Again, just remove the ceiling. The ceiling function just keeps you in a very narrow width 1 interval. So if you take the square, I'll just take the plus square roots. I'll write down plus or minus if you want, but that would be plus or minus. Remember, this is 560 to the 1/2, so this would be 560 to the 1/4, and you can write it like this. Right? So you can see why we're interested in this particular inequality right here. Okay, there we go. All right, now let's move along. Now, and also it follows very quickly from just the nature of the ceiling function that both the ceiling and the value of x have to be also trapped between these two numbers. And again, that's just pretty much clear. I don't know, I don't want to try to explain it. It's fairly obvious just based on the way this expression is formulated. All right. So now, so we see quickly that the ceiling of x, if x is less than the square root of 24, has to be 5. Remember, the square root of 25 would be 5. And just by the form of the original equation, the ceiling of x times x has to equal to the square root of 560. X would have to be the square root of 560 over 5, so the 5's would cancel, right? Okay, so in other words, this happens by force. So I'm claiming that this is the answer. And the part that I guess if you want to call it a challenge, once you determine the ceiling of your number in a particular interval, you're just about done with the problem, because this would be the only choice where you would have the 5's canceling and you would still have the square root of 560 left up here. I'm sorry, I'm not quite keeping that on the same screen for you guys. But hopefully you see why that would be the answer. Now, we could leave it that way, or we could keep going a little bit if you want to. This would be equal to 560, I think is, let's see. And again, y'all, this is the answer, and some people don't care about rationalizing anything. This is the answer to the problem. However, a lot of people like to pretty things up. So 560 is 3 times 5 times 16. Okay, so that will explain some of the next steps right here. The very next step would be you would get that this is equal to And again, you can see some of the cancellations that are going on right here. this would be 1/12 over 5. Right, folks? Because if you put the 5, that radical extends all the way down, right? Okay, that's the square root of 1/12 over 5, because if you put 5 in here, that would be the square root of 25. So one of these 5s would come down, right? And I think, let's see, did I get this right? 3 times 5? Or is that 7? No, okay, I think, yeah, okay, we got it going on here. Okay, now notice here, though, that this is also 1/12. I'll just write out the answer, folks. Okay, this would be equal to 4. You don't want to sit around and watch me do the arithmetic, but 7 times 16 is 112, right? 7 times 16. So you can take the square root of that and you get 4. So this would be 7 over 5 here, right? Again, folks, 7 times 16, I'll at least say it. The square root of 16 is 4. That's where this 4 comes from. And also, a lot of people don't believe in leaving the answer this way. And so you can multiply top and bottom by root 5 over root 5. Or you're multiplying through by a cleverly disguised version of 1. And I don't like any of this very much. I know there's probably some benefit somewhere. As far as I'm concerned, that's the answer. I guess this is, who knows, just something for people to assign. But anyway, this would be equal to 4 over 5, right? See how this is all going to work out? 4 over 5 times root 35. Okay, so I guess in a way this is it's easier to estimate what this number is equal to, right? I guess that's a good reason. If you look at this, you're going, what is this? This is a number pretty close to 6, so a nice fractional approximation would be 24 over 5, right? 24 over 5, which would be very close to whatever this is, I think. All right. So these two equations are quite related, but they are different. So that's what makes it a little bit more challenging. So anyway, you can call this the simplified form right here, 4/5 square root of 35. I hope you like that, because I see a lot of these kind of problems on the web where they always just put some small integer out here. I think it's nice to put an irrational number out here and kind of test it a little bit, because the number sense seems to diminish once you put anything but a simple integer here. But anyway, that's all, folks. Thank you for viewing. And this is x. Yeah, it's x all the way through here. I kept it straight. Okay, thank you.